Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, guys, we're going to wrap up the quadratic and rational inequalities, rather, how to solve them. We talked about how to solve quadratic inequalities yesterday in detail. We learned our little trick, the greater and the less than. And now we're going to talk about rational inequalities. Now, as far as a rational inequality goes, it is an inequality that contains a rational expression. Well, what's a rational expression, Morrow? That may be a question you're asking. A rational expression is any expression where you have a variable in the denominator. So, for example, all of these are examples of rational inequalities. This guy right here, because the x in the denominator, okay? This guy, because you have x's in the denominator. Oh, and that one too. Here you have x's in the denominator. Here you have x's in the denominator. So whenever you have an expression or an equation or an inequality, in this case, where you have x's or variables rather, not just x, variables in the denominator, that's a rational expression. So how do you solve rational inequalities? Good news, you're not going to have to graph it, okay? We're going to do this algebraically as well. If you can tell, we didn't really learn, well, we learned how to do it, but solving a quadratic inequality, graphing it is not the most efficient way, and you have that whole shading issue. So the same thing happens here. So it's very similar. I will say the greater and the less than trick does not work with rational inequalities. That does not work. So you cannot use that trick. Sorry, guys, we're going to have to actually test it out, okay? But let's get to it. So, okay, so first, for a rational inequality, since you have variables in the numerator and the denominator, or at the very least in the denominator, you're going to set the given inequality to 0, okay? So that a single quotient or simplified rational expression is formed on one side. This is what you want right here. If I had, for example, a 5 here, I would have subtracted 5 to both sides because I want a single quantity. I want everything on one side, okay? In this particular case, I already have everything on one side. It's greater than or equal to 0. Step 2, we're going to find the zeros and the undefined values of x. What are zeros? Well, we're going to find the zeros in red by setting the numerator of the rational expression equal to 0. So my zeros, those are my solutions. Remember, zeros, roots, x-intercepts, those are my zeros. I'm going to set x plus 3 equal to 0. So x equals -3. That is valid. That works. That's a potential solution. That's golden. Next thing you're going to do is you're going to set the denominator not equal to 0. Why do you think for the undefined or restrictive values here, why do you think I have to set the denominator not equal to 0? Why do you think not equal to 0?
Because if you set it equal to 0, then it would be a 0 once you solve it in the denominator, and you cannot have the 0 in the denominator.
Thank you very much. You cannot have a 0 in the denominator, guys. It's illegal. You just can't do it. You can't do it. So whenever you have a 0 in the denominator, it's undefined, and you cannot do that. All right, sir? That's not what I said to plug in a 0. I am setting the denominator not equal to 0. So x cannot equal 4. It can equal any other number in the universe except 4. You just can't do that, guys. Okay, because if x is 4, 4 minus 4 is 0. And you're out of luck, Chuck. Now you have an undefined value. So everyone understands how I found my zeros in red and my undefined values in blue? Everybody? Okay. Now, plot the zeros and the undefined values or the restrictions on a real number line and test each interval in order to find the sign of your original rational expression. Again, remember that a negative over a negative is a positive, and a negative over a positive is a negative. So, what do I do here? On my number line, again, you cannot use the trick, guys. I am sorry. You cannot use it. Now, oh, come on, Moto. Pay attention. So, check this out, guys. The negative 3 definitely can work. But the negative 4 will never work. So you know, the positive 4. So you know what I have to do here to show myself? I'm going to put a circle around that 4 because circle means it's not included. You got to use it for shading purposes, but it is not included. So when you're writing the solution to this, if that's part of it, that has to be in a parenthesis, not a bracket, because it cannot equal 4. So now I have, again, 1, 2, 3 testing intervals. Let's try testing interval 1. If I go to the left of 3, I get a negative, let's try negative 4, right? Okay. Guys, if I have a negative 4 plus 3, that's a negative 1, correct? Over a negative 4 minus 4, it's a negative 8. What's a negative divided by a negative? Is a positive greater than 0? So that works, this does not, and that works. That also is always consistent. If the first one works, guys, now that's going to be a bracket because it's greater than or equal to, in union with parentheses, 4 to positive infinity. Why parentheses? Because x cannot equal 4. Yes, sir, I saw a hand. No, I said the greater or less than is not going to work. Now, you may be saying, wait a second, Moro, but in this case, it did work. Yes, in this case. But this one, guys, I tested that trick out here, and it did not work always. Does it work like 80% of the time? Yes, it does. It works a lot. But as a teacher, I cannot tell you, hey, use this trick always unless it's really always. Okay? Now, what does work is this, brother. We talked about this trick yesterday. If the first one works, the last one has to work, period. If the first one does not work, then the middle one does and the last one does not. That is consistent. But the greater and the less than trick, that's only for quadratic inequalities and absolute value inequalities. Thank you, sir. Yes, sir. Okay, well, let's test this second guy. When x is 0, what's 0 plus 3? Okay, and then 0 minus 4? A positive over a negative is a negative greater than 0? So that does not work. Well, if this one did not work and this one did not work and this did, then it would be between negative 3 and 4. But a negative 3 would be in bracket because it's greater than or equal to, and the negative 4 would be in parentheses because it's not equal to that. But I'm taking that off because that is not what the case is. Okay? Does that make sense, guys? Pretty simple. Find your 0, find your restriction, put it into the graph, and find your solutions. Literally that simple. So let's get to it. Please and thank you. All right, super simple. Always follow the steps. What's my 0? X equals positive 7. What's my undefined values or my restrictions? Restrictions or undefined values. Not 3, no. X cannot equal negative 3. Get your vocabulary, guys. It's all about vocabulary, okay? If I tell you, hey, make a left at the street light, and you don't know what a street light is, isn't it very difficult to make that left, guys? Be honest. You know, let's say you're from a foreign country and you don't know the language. I go, oh, make a left in the street light. You're just going to look at me and you don't know what I just said. Vocabulary in math is the same way, my brothers, okay? So now, make my number line. I'm going to put a circle around the negative 3 because it cannot equal negative 3. I want to remind myself because I make a lot of mistakes. I'm human. So you have test interval 1. In between negative 3 and 7 is test interval 2. And to the right is test interval 3. Just so you guys know, you're always going to have one more test interval than solutions. So if you have 1, 0, and 1 restriction, you're going to have 3 test intervals. Let's say you had 2 zeros and 1 restriction. You're going to have now 4 test intervals. Okay, and I'll show you what that looks like in a second. So to the left of -3 is -4. A negative and a negative up here would give you a, no, a negative. I don't even care about the value if you've noticed, guys. I don't care about the value. I care about the sign. A -4 minus a 7. A negative plus a negative is going to be a negative. Now down here, a -4 here. If you had a -4, is this going to be positive or negative? What's a negative divided by a negative? Is positive greater than 0? This works. This does not. This works. My answer is -infinity to -3, parentheses, because it can't equal 3, in union with bracket 7 to positive infinity. I know that some of you are saying, Moro, the great Tor thing worked again. I know. It's going to work most of the time. I just cannot tell you it works always. I'm sorry, guys. I don't want to mess you up later. You with me here? All right, let's do it. Let's get it. All right, now here. Whoa, hey, whoa. What do we got to do here first? Subtract the 2. Very good. So I'm going to subtract 2 to both sides. So I've got x plus 3 over x minus 1 minus 2 equals 0. Now, here we have a little bit of a situation, guys. So let me take you back in time real quick, all right? I'm not trying to be condescending with anyone. I'm trying to show you how easy this is. If I had 1/3 plus 1/5, guys, how do we add those? Common denominator, right? What do I got to multiply to 3? Well, what's the common denominator? 15. What do I have to multiply to 3 to get to 15? Great job, guys. And what do I need to multiply to 5 to get to 15? Okay. So you're going to multiply the same thing to both the numerator and the denominator, right, gentlemen? Again, no sarcasm at all. You see that, right? You all said it. You all answered it. Super easy, right? Take a deep breath. Take that same confidence, okay? Seriously. And apply it to this right now. Chill with me. I got your back. Guys, there's an invisible denominator of 1, right? Okay. Focus. Take your time. What's the LCD? Good. X minus 1 and times 1 is x minus 1. Correct, guys? You with me? Just like here, how did you find the LCD? Was 3 times 5? 15, right? You guys with me? What do I need to multiply to this guy to get x minus 1 as a denominator? X minus 1. So now I have x plus 3. Distribute that, thank you, minus 2x plus 2 over the common denominator of x minus 1. Is everyone with me? Yeah, but we're setting it equal to just to find the values. Thank you, Papo. I don't worry about the greater than or equal to until the end when I'm testing. But thank you, sir. Is everyone with me here, guys? Okay, so then this is going to be negative x plus 5 over x minus 1. Yeah, just to have that reference. Now I have my inequality. You feel me? Now, what's my 0? What is it? Yeah, because negative, yep. So x equals 5. And what's my undefined or my restriction? X cannot equal 1. No, 1 and 5. Okay, so to the left, in between, and to the right. Interval 1, interval 2, interval 3. Let's see what works. Okay, guys, to the left, interval 1. Let's try 0. If I plug in 0, what am I going to get? All right, guys, sorry about that. So test interval 1, let's check 0. So if I put 0 here, 0 plus 5, we got a positive up there. 0 minus 1, we got a negative. What's a positive times a negative, guys? Negative. So is negative greater than 0? This is why you never use the greater or less than. This did not work. That does not work. That does. My solution is between 1 and 5. 5 with a bracket. Do you guys see why you don't use the trick now? Promise me? May I continue? Thanks, brothers. Okay, right here. Now, in this particular case, okay, I just got a bunch of different zeros. This is what I was talking to you about. Now, you're going to have 3 different values. You're going to have two solutions, and you're going to have 1 restriction. Zero product property, guys. So what are my zeros? Remember, we're setting this equal to 0 and this equal to 0. What are my zeros? X equals 2/5. Thank you. And thank you, my brothers. And what are my undefined values or my restrictions? X cannot equal 5. Thank you, brothers. So it cannot equal 5. I'm going to circle that because I forget things. 2/5, I'm not going to circle because it can be a solution. -4, I'm not going to circle because it can be a solution. Now, remember what I told you, brothers. You're always going to have 1 more testing interval than you do solutions. So I have 3 different solutions here, right? I have a restriction and 2 zeros. So I have test interval 1, then test interval 2, then test interval 3, then test interval 4. Look at my test intervals. I went to the left of 4, in between -4 and 2/5, in between 2/5 and 5, and then from 5 to positive infinity. Do you see how and why I did that, guys? Yes, sir. Thank you. Okay, because I'm going to mark in red I have this guy, and this guy, right? So my solutions can either be to the left of 4, in between 4 and 2/5, in between 2/5 and 5, and then from 5 to positive infinity. Thank you so much, kid. Thank you. So let's test, guys. Let's test. And remember, this is why I don't do values. I don't care about values. I don't care if it's 8 times -7 times 5 times 2/3. I don't care about that. I care about the sign, positive or negative. So think about it the way I think about it. I'm going to use -5. A negative times a positive is a negative, right? And a negative plus a negative is a negative, right? So that's negative. Here I have a -5. That's a negative as well, right? Okay. And then I have a negative, so a negative plus a negative is a negative, right? What's a negative times a negative? Divided by a negative? So does that work? So now, this guy will work and this guy will work. This guy and this guy will not. I'll prove it to you. Let's do when x is 0, we'll do it in blue. If x is 0, that's a negative. If x is 0, that's a positive. If x is 0, that's a negative. What's a negative times a positive? Divided by a negative? It's a positive. It does not work. That will not work either. Does that make sense, gentlemen? So now my solutions here. I've got from -infinity to -4, and that's a bracket in union with, bracket, 2/5 to positive 5 with parentheses because 5 cannot work. Now, for those of you that are like, okay, Moore, you're usually right, but I don't really believe you for this third one. I think that could be wrong. Well, let's test it out. Let's use the value 1, okay? And we'll use the value 1. Let's erase some of this to make it clean. And let's do purple. So when it's 1, well, if it's 1 there, that's going to be a positive, right? And a 1 here, that's going to be a positive, right? And then a 1 here, that's going to be a negative, right? So a positive times a positive is a positive, divided by a negative is a negative is less than 0. So that's why this guy works. Yes, sir, my brother. You can choose any value as long as it's between those testing intervals. As you can see, my brother, I've been going for the easiest numbers. I'm not going to convolute my life. If it works for one number in that interval, I promise you, it works for them all, kid. Sir, I circled the 5 because x cannot equal 5. So think about it. If I told you x is greater than 2, remember we're going back in time now. Wouldn't I put an open circle to the right because it's not included? In interval notation, it'd be a parenthesis. If it was x is greater than or equal to 2, if you remember, it'd be a dot or a bracket. So then it would be bracket 2 to positive infinity. Make sense? Thank you, brother. May I continue, gentlemen? Okay. Let's do this. Okay. Ooh, there's a tasty one. Okay. We're going back to, we have some sort of fractions here. What the? First, find the LCD. What's the LCD, guys? No. There's an x plus 3, but there's also a separate. So, it's the product, guys. Oh, no, don't convolute it. I'm so proud of you. But don't combine them because it's going to be really hard to know what's missing. Let me explain what I mean. There's an x plus 3 and an x. So my LCD is an x times an x plus 3. If you go like this, guys, you're going to make your life miserable, and I'll show you why. If you leave it like this, like you should, guys, what do I need to multiply to this guy to get the denominator that I want? What is this missing? Guys, what is it missing? Yeah, so you multiply an x to both top and bottom. Would you know, so this would be 2x over x plus x times x plus 3. If you had put it like that, would it have been easy? Would you have known what to multiply? No. But look, guys, here, my LCD is x times x plus 3. What do I need to multiply to this to make it look like that? The x. So 2 times x is 2x over x times x plus 3. You with me? Plus, what do I need to multiply to this? Yeah, what is that missing from the denominator in x plus 3? So I got 2 times x plus 3. So now I have 2x plus 2x plus 6, which is 4x, plus 6 over x times x plus 3. And this is less than or equal to 0. This is now my jumping off point. Talk to me, please, before I continue. And we got plenty of time. And this is the last lesson. So talk to me, brothers. How can I help you? You guys with me? Okay. So I'm going to expand again. You got it? Okay. Thank you, guys. All right. So let's continue. What are my zeros, gentlemen? Negative 3/2. X equals negative 3/2. Right? Because you go 4x plus 6 equals 0, negative 6. 4x equals negative 6 divided by 4. X equals negative 3/2. And then what are my restrictions or my undefineds? X cannot equal 0 or negative 3. Remember, the denominator must be set not equal to 0. Okay? Is everyone with me? So now, my number line. Negative 3/2, negative 3, and 0. Okay, remember, undefined cannot, so I need a circle here and a circle here, because those cannot be solutions. And now I have 3 values, so I'm going to have 4 intervals. To the left of negative 3, in between negative 3 and negative 3/2, in between negative 3/2 and 0, and to the right of 0. 1, 2, 3, 4 different test intervals. Let's go. Let's go to my first test interval. And before I do that, though, let me show us. Okay, let me get this here. Wait, let me get this here. There we go. Oh, hold on. Let me do this. There we go. Okay, now we can test it easier. Okay, so -4. If I put a -4 here, what's the sign of this going to be? A negative, right? Because I'm going to have -16 plus 10, so a negative. I don't care about the value, I care about the sign. If I have -4 here, this is a negative, and this is going to be a negative. What's a negative times a negative? What's a negative divided by a positive? Negative. It's less than, right? So this works, that does not, that does not. So this is negative infinity to -3 parentheses because -3 is a restriction in union with -3/2, which is a 0, and it's a bracket, comma, 0, which is parentheses as well. Does that make sense, gentlemen? Correct. Parentheses means that it cannot equal that. Bracket means it is included, yes. So yeah, so what this guy here means, it means it can go from negative infinity all the way to like, you know, negative, no, not -3 million, because it can only go up to -3. So remember, the larger, the more negative you go, the bigger. So this could go like to all the way like right here, right there, which would be, 4.0001, right before that -3. But it's not going to equal the 3. That's what the parentheses tells you. Because if it equals -3, I have a 0 in the denominator, and it's undefined. So, my brother. Yeah, the undefined. I set the denominator equal to 0. So this is my denominator, right? X times x plus 3, right? So I set x not equal to 0 and x plus 3 not equal to 0. So x cannot equal 0 or -3. You got it? Sure? Thank you, brother. Any other questions, gentlemen? All right. How about this bad boy right here? Good. Last one. We got plenty of time. All right. This is a good one. Okay. Here. Here. What do we do? What do you think I do first? Good. Thank you. Set it to 0. So I'm going to subtract 3 over 2x plus 1 to both sides. So I'm going to have 1 over x minus 4 minus 3 over 2x plus 1 is greater than or equal to 0. What's my LCD? X minus 4 times 2x plus 1. Because I need this guy and this guy combined. Guys, it's just like if I said 1/4 plus 1/7. The LCD here is 28, right? 4 and a 7. 4 times 7. Okay, so what do I need to multiply to this guy here to get the denominator of x minus 4 times 2x plus 1? What is this missing? So let's go 2x plus 1 to both top and bottom. Numerator and denominator. 2x plus 1 minus, what do I have to multiply to this guy? What is it missing? On x minus 4. Very good. So I'm going to multiply an x minus 4 to top and bottom here. And I'm distributing a -3. So that's going to be negative. So this is plus a -3x plus 12. Now, what am I left with? 2x minus 3x is -x plus 13, good, over x minus 4 and 2x plus 1, and all of that is greater than or equal to 0. Talk to me, please, before I go any further. You got it, Bubble? All right. What are my zeros, guys? Well, you set negative x plus 13 to equal 0. So negative x equals negative 13 divided by negative 1, x equals 13. What are my restrictions or my undefines? X cannot equal 4 or, thank you, negative 1/2. Beautiful. Beautiful. By the way, every part here is, partial credit. You get this part, you're going to get credit. You get the undefined and the zeros, you're going to get credit. Now, last step, see what you got. I've got negative 1/2, which cannot be, a 4, which cannot be, and a 13. So I'm going to have 4 intervals. And like always, let's test my first interval. To the left of negative 1, of negative 1/2, I'm going to do negative 1. So a negative and a negative, that makes that a positive, right? And then a negative and a negative down here, that's a negative. And a negative, that's going to be a negative as well. So a positive divided by a positive is a, so this works, this does not, this works, this does not. And my answer is negative infinity to negative 1/2, parentheses, union with 4 to 13 in brackets. Yes, no, maybe, kind of, sort of. Yes, sir. Yes, sir. No, it's between negative 1/2 and 4, my man. Because those are, 0 is not a 0. 0 is just my place value. It's just to keep me in balance. That's why, if you notice, I went from here all the way to here. Thank you, my brother. Last but not least. All right, guys. Solve. Function r of x is greater than 0 if r of x equals x plus 3 over x minus 8. Well, okay. Let's think. This is the function itself. And that function has to be greater than or equal to 0. So that means that the function itself, which is x plus 3 over x minus 8, must be greater than or equal to 0. Some people may say, Moro, why did you give us such an easy one? Is it really that easy? Will everyone realize that the actual function itself is this guy right here? Will they realize that? I hope so. Rx is this guy right here. Why I make such a big deal about this is because a lot of times, I don't know why, but people will make it like this. Yeah, I don't know why they would do that. But the function itself, r of x, is greater than 0. This is the function. So that has to be greater than or equal to 0. And now, my zeros, I'm going to fly through this one. My restrictions, or my undefines, x cannot equal 8. 8 can equal it. So I go to the left of negative 3 between 0 and 8, and to the right of 8. Okay, to the left of negative 3 is negative 4. A negative 4 and a positive 3 is going to be a negative. A negative and a negative is going to be a negative. A negative divided by a negative is a positive. That works. That does not. That works. Brothers, we just destroyed this. We just destroyed it. Talk to me, please. Questions, comments, concerns, anything at all. I got the time. Talk to me. Sir, my brother. Which is right here.
Let's say you would have 2 over x plus 3 as it is, and then
Yeah.
let's say 3x as your denominator. Would you do that?
Well, that'd be a completely different problem now. If this was a 3x here, then my LCD would be 3x times x plus 3. So now what would I have to multiply to this? What would it be missing? The 3x, man. Not the 3, the 3x. This is x plus 3. They're two separate polynomials. This is a binomial. That's a monomial. What would I have to multiply to this guy? What is this missing? The x plus 3. Good man. Exactly. And then you'd go from there. Cool? Thank you, my brother. Anything else, gentlemen? Word. Thank you very much. Hope you learned a lot. God bless you, and have a wonderful day. Bye-bye now.